This is part 2 of simple truss. All right, we had just spent some time on pin C, and I want to recap that because I was doing that too fast. So this is pin C. And here I have BC, and we'd already decided it was 100 compression, so we draw that in like that. We have AC, which we had just worked out was 141 tension, and so I draw that. And remember, these internal forces must cancel one another out. And then we have unknown force CD going off in that direction, and we have unknown force CE going off in that direction. So considering CE, because 141 is going in the downward direction, I propose we put CE going up. And then I don't know what direction to assign to CD, but let's just give it that for now. So we make intelligent guesses about what directions these members have, and if we're wrong, we're wrong, and we just reverse our mistakes. So we're applying the equations of equilibrium now to this pin. So let's do some of the forces in the y direction first and set them equal to 0. And so we're going to have this is going to be a negative 1 over square root of 2 times 141 plus CE is 0. Therefore, CE is equal to 100. And because it's pointing into the pin, it's in compression. So CE is 100 compression. And we found CE, so good for me. Sum of the forces in the x direction, set them equal to 0. Let's see what we get. So I have CD going off to the right. I have another 100, and I have minus 1 over root 2 times 141. And since 1 over root 2 times 141 is equal to 100, we conclude that CD is 0, so we have another 0 force member. This is 0. And now, let's just kind of summarize where we are all over this truss. We have found, we have finished finding CD, so that one was 0. We had previously found that. And the only thing left for us to figure out is DE. So let's go ahead and draw a free body diagram of pin D. All right, so this is all that's going on with pin D. All right, it's got this and this. All right, and even if we were just beginning at pin D, and so the name of this is ED, and the name of this is CD. Right? Even if we were just beginning at pin D, and I don't know, let's put some arrows on here. It doesn't matter which way I draw them. When you sum the forces in the y direction and set them equal to 0, we see that ED is 0 immediately. Right? And when we sum the forces in the x direction and set them equal to 0, right, we see that CD equals 0. Right? So when you've got kind of a dangling corner thing out there with no loads at the tip, these both can be recognized by eye as being 0 force members. And so the last thing I kind of want to point out is that ED is equal to 0. And so now we have completed solving this truss.